Everyone, today we're going to do a problem where we are asked to find all possible values of a. A is found in the denominator of this binomial expansion. If the coefficient of the term in that binomial expansion of x cubed is exactly 288. Okay? So first off, let's write down our general formula for the r plus 1 term. You'll see why in just a sec if you don't remember, is n choose r times the first part of the binomial. So our a, the first part of the binomial, is 2x, and the second part, what we call b, is going to be 1 over ax squared. Our general formula for the r plus 1th term is n choose r times a to the n minus r, n being the exponent on that binomial, times b to the r, right? So if we want the term in that binomial expansion that will have an x cubed in it, then we can look at plugging in 2x in for a, 1 over ax squared in for b, n for us will be 9, and then we can play around with the rest of it, okay? So we'll say tr plus 1 will be 9 choose r times a, I'll remind you, is 2x to the 9 minus r, right, times 1 over ax squared to the power of r, right? With this specific binomial in mind, this is going to be our general r plus 1th term in that expansion, okay? Now, 9 choose r, we can leave for now. We want the term that provides us with an x cubed, right? That x cubed, right, this is just going to be some numerical value. That 9 choose r is not going to contribute to that x cubed, to the exponent on the x, right? The 2x to the 9 minus r and the 1 over ax squared to the r, those are going to combine to make an x cubed, right? And so let's simplify this portion, okay? So that means that 2x to the 9 minus r, that means 2 to the 9 minus r times x to the 9 minus r, right? Our basic exponent laws, the 9 minus r hits the 2 and hits the x as a product, times 1 over the r again, we'll hit each part, so that'll be a to the power of r times x squared to the power of r. When we have a power to another power, we can multiply the exponents, and so that'll be x to the 2r, right? And we're looking for when this produces an x cubed, right? And so if we simplify that, that is going to be, I'm going to leave the 2 and the a stuff in front because those aren't contributing to the exponent on x. So we'll have 2 to the 9 minus r divided by a to the r, right? We can deal with that a bit later on. But then we'll have times x to the 9 minus r divided by x to the 2r, right? That's what's going to contribute to the x exponent. And we want to know when that produces an x to the power of 3, right? And so if we focus on this part of our expansion, we get, again, by exponent laws, and we divide terms with the same base, we can subtract the exponents. This produces an x to the 9 minus r minus 2r. 9 minus r minus 2r. We're dividing by x to the 2r, so we subtract that exponent. And that means that is x to the 9 minus 3r. 9 minus 3r. We want to know when that is equal to x to the power of 3, right? And so I'll bring that over here. When is x to the power of 9 minus 3r equal to x cubed? Question mark, right? Well, that's easy enough. We can set this up as an equation. We have the same base, so we equate its exponents, and so we get 9 minus 3r minus 3 equal to 3. Not too terrible to solve. subtract 9, excuse me. So negative 3r is equal to negative 6, right? And finally, you guys get it. Divide both sides by negative 3, and we get r must be positive 2. Okay? So r being positive 2 means that we are looking for the r plus 1th term. So we're going to look for the third term, right? So if we plug this into here, t2 plus 1, which is t3 for the record, that is going to be 9 choose r is 2, we found. So 9 choose 2 times 2x to the 9 minus 2. So that'll be 7, right? 9 minus 2, 7, times 1 over ax squared to the power of r, to the power of 2, times 1 over ax squared, right? And we found that that was going to produce something, namely 288 as the coefficient times x cubed. And so that third term we know is going to be 288x cubed, okay? And that is what will allow us to set up an equation to solve for a, because in the end, we want to solve for all possible values of a. And so that means that now we can set this up. So we have 9 choose 2. 9 choose 2 is, that is 9 factorial over 7 factorial, 2 factorial, times, let's take the numerical portion because we're going to set up an equation with the coefficients, right? We know the x cubes. We know we're going to have x cubed in both sides of the equal sign. So let's work with the coefficients so that we can actually solve for the values of a. So we have 2 to the power of 7, 2 to the power of 7 times 1 over a squared, right? Everything else has to do with the x's. We know the x is going to be x cubed on both sides. That was our entire guiding force in setting up this equation. So we want to equate the coefficients, right? That is what we're told. The coefficient of x cubed is 288. And so we can set up an equation to solve for a. And so all of this must be therefore equal to the coefficient on the right-hand side, which was established in the beginning as 288. And now this is an equation. The only unknown is a. Let's algebraically solve for it. So 9 factorial over 7 factorial, 2 factorial. That means the 7 factorial will cancel out. So all that'll be left with, it'll be 9 times 8, which is 72, divided by 2 factorial. That's 36. So we'll have 36 times 2 to the power of 7 is 128 times 1 over a squared is equal to 288, right? Then we can divide both sides by 36 times 128, 36 times 128, divide by 36 times 128. And so that will bring us to, I'm going to try to organize this solution as best as I can. So we will have 1 over a squared being equal to 288 over 36 times 128. You can try that on your own. I'm going to throw that into a calculator. And that'll be 288 divided by 36. Careful with your brackets when you're punching this in. That'll be what is that as a fraction? 36 times 128. That is 288 over 4608. And I'm sure we can simplify that. 5. Yeah, so that simplifies down to 1 over 16. Turns out you can simply do this step by step, slowly simplifying your fraction down to its most simplified form, to its irreducible form, and you'll get 1 over 16. And now, if 1 over x squared is equal to 1 over 16, then we know the reciprocals are also true, and so that means that a squared is equal to positive 16, and that would mean, hence why they ask us to find all possible values. If a squared is equal to 16, then we get a is equal to positive 4 or a equals to negative 4, both being perfectly viable solutions. And so there we go. So there are different ways to go about this. You could have expanded this out and maybe noticed the pattern for yourself and done it a bit differently. I wanted to start with the general r plus 1th term formula, go from there, find the value of r that produces whichever term. We didn't know for sure it was going to be the third term. Don't be misled by the idea that the third term necessarily produces the term with the x to the power of 3. That's not always the case. It just so happened to be the case this time. But we found the r value to plug in to get a specific term. We plug r in to our general formula with a and b, and then we equated the coefficients, knowing that x cubed was going to be present on both sides of this equal sign, x cubed and x cubed. So then we equated the coefficients, and that allowed us to solve for a. So I hope this helps. Thanks for watching. Please leave a comment if you have any other suggestions on the binomial theorem for future videos, and I hope this helps.